find the shaded parts in this example, we will have to subtract the area of the circle from the area of the square. Now, how do we find the area of the square? We can see that the diameter of the circle is actually equals to the side of the square. So to find the area of the square, we just have to multiply diameter by diameter. And to find the area of the circle, the formula will be pi multiplied by radius multiplied by radius. So this will give us the formula to find the area of the shaded parts in this figure. Our next example is a square within a circle. We can see that the square is now smaller than the circle. So to find the area of the shaded parts, we take the area of the circle to subtract the area of the square. But is the side of the square equal to the diameter of the circle as in our previous example? This is the diameter of the circle. This is the side of the square. We can see that the side of the square is actually shorter than the diameter of the circle. So therefore, we cannot find the area of the square by multiplying diameter by diameter. Then how do we find the area of the square? First, we draw the diagonals of the square. We can see that the diagonals of the square intersect at right angles in the center, and they also bisect each other at the center. Therefore, the diagonals of a square actually cut the square into 4 identical right-angled triangles. You can see that the base and height of each triangle is actually the radius of the circle. To find the area of the triangle, we use the formula of half multiplied by base multiplied by height. Therefore, the area of one triangle will be half multiplied by radius multiplied by radius. To find the area of the square is the same as finding the area of 4 triangles. Therefore, we take half multiplied by radius multiplied by radius multiplied by 4, and that will give us 2 multiplied by radius multiplied by radius. Of the shaded parts for a square within a circle, we take area of circle, take away area of square. The area of circle will be pi multiplied by radius multiplied by radius, and the area of the square will be 2 multiplied by radius multiplied by radius. So that will give us the formula to find the area of the shaded parts in this example. Next, we're going to take a look at the L bracket. In this figure, we can see that the shaded part resembles the letter L. So we call this the L bracket. So how do we find the area of the L bracket? To find the area of the L bracket is like taking a piece of square paper and then you cut a quarter circle from it. So this is the same as taking the area of the square, take away area of the quarter circle. Now we can see that the side of the square is actually the radius of the quarter circle. So to find the area of the square is the same as multiplying radius by radius. And to find the area of the quarter circle is half multiplied by pi multiplied by radius multiplied by radius. Therefore, this will be a formula to enable us to find the area of the L bracket. Now, this is an example of a figure that involves the L brackets. You can see that there are actually 4 L brackets in this figure. So to find the area of the shaded parts is the same as finding the area of one L bracket, and then you multiply its area by 4. Alternatively, we can also take the area of the big square and take away the area of the circle as in our first example. If I read brackets, you will get more examples such as this, which you can see 4 L brackets there, or you take the area of the square, take away the area of 2 semicircles, or you may see something or this. So in all these examples, we can make use of the L brackets to find the area of the shaded parts. Next, we are going to look at the half petal. The shaded area in this example resembles half of a petal. So how do we find the area of this half petal? This is the same as taking a quarter circle and then you cut the right angle triangle from it. So therefore, we take the area of the quarter circle and take away the area of the triangle. Now the area of the quarter circle will be 1/4 times pi times radius times radius. How about the triangle? Now, in this triangle, we can see that the base and height of the right angled triangle is actually the radius. To find the area of this triangle is half multiplied by radius multiplied by radius. So therefore, this is our formula for finding the area of the half petal in this example. This is another example that involves the half petals. In this example, we can see 4 half petals there. If I rotate the shape, we have another example here. So to find the area of the shaded parts is the same as finding the area of 1 half petal, and then you multiply its area by 4. Alternatively, we can also take the area of the circle to take away the area of the unshaded square. This is same as the second example where we have a square within the circle. From the half petal now, we are going to go to the petal. Now, if I cut the petal into halves, you can see that the petal is actually made up of 2 half petals. So to find the area of the petal is the same as finding the area of a half petal first and then multiply the area by 2. Another method of finding the area of the petal is to take the area of the square and then you subtract the 2 L brackets, which are actually the unshaded parts. So this is another method of finding the area of the petal. Now the example shows over here is a figure that is made up of 4 petals. So to find the area of the shaded parts is the same as finding the area of the 4 petals. What you can do is we can cut each petal into half petals. So the area of the 4 petals is the same as the area of 8 half petals. Now in the previous example, we already learned how to find the area of the half petal. We take the area of the quarter circle to take away the area of the triangle. So this is the area of a half petal, and since there are 8 half petals here, we multiply this by 8 and that will give us the total area of the shaded parts in this example. This is another figure that involves petals and L brackets. Right, in this example, we can see that the 4 unshaded parts in this circle are actually the 4 petals, and then the shaded parts are actually made up of 4 L brackets. We have another example here. If you look carefully, you should be able to identify the half petals in this example, which are actually the unshaded parts.